So are you all ready?
I'm ready. People need to come back in first.
Yeah, let me let's start a couple minutes late. Let me get people going. Hey friends, we're going to start the automated testing session. If you want automated testing, come on in. All right, this is probably good enough to start. Yeah.
All right, is everyone here?
The people who are not here, we're not being able to answer. So. It's live now?
Okay, cool. Hi guys, my name is Jason. I've been a backend developer for about 3 years. Been helping out CodeSeoul, and today I'm going to be talking about automated testing. Who has heard of software testing or tests in general? Raise your hand. Okay, who has not heard of it? Okay, cool. For the people that haven't heard of it, software testing is just a way to verify that your code works the way you expect it to. And there are manual types of testing where we actually, in this case, for a server, we spin up the fast API server and then we check the endpoints using like a tool like Postman or through a Open API Swagger docs. You can do it through that way in a manual way, but we do not want to do it in a manual way because it is a huge, humongous waste of time. It's like watching paint dry on the wall if you're doing a manual testing. It is so boring. Do not ever do it. Please do not ever do manual testing unless you really have to. Always find ways to automate testing because testing is like having a seatbelt on, except we have to build our own seatbelt because the seatbelts don't exist in our case, right? So we're going to talk about automated testing. Let me start the presentation. All right, so what is automated testing? I talked about it right now. So automated testing, just a little bit more. We write test code that we run, and the test code just verifies that the code that we wrote works in a way that we expect it to work, right? And we do have to use special different packages for that. In Node, there's Jest. In Python, there's unit tests, but we're going to be for this bootcamp going to be using PyTest. And for every other language, there's always a testing library that we'll be using, right? So the types of tests we're going to cover in our bootcamp and in general is the 3 tests: units, integration, and end-to-end. There are 4 more tests, types of tests that we can do for our software, but we don't have time for that. And I found that these three tests, they kind of cover most cases that we are trying to do. So to explain what these things are, unit tests, they are testing functions or just methods or just little pieces of code in isolation from everything else. So if you have a function that calculates the distance between 2 coordinates, you can test that just by itself to make sure that it calculates correctly, right? Integration tests are when we want to is to verify that different modules or services or any kind of different outside service interacts with our code base in the way that we expect. So for our case in the server, we do have code that interacts with the database. We would write integration tests to verify that the database and our code interacts in the way that we expect, right? And the end-to-end test is the final kind of test that we'll be talking about. It replicates user behavior within the software, right? So in our case, we have a server and a client will make a request to the server. So what we'll do in the test is we will spin up a test instance of the server. The test code will allow us to do that. And then we will make a request to that server just using like Is someone getting a call? Okay, cool. We will make a call to our test server using the test code to verify verify that the code works in the way that we expect, right? Otherwise, we have to do all of this manually, which takes a lot of time and it's just really, really boring. So please don't do it unless you really enjoy it, you know. Then I'm not going to stop you, right? So yeah, we're going to be using PyTest. It's become very popular because it's just very, very simple and very easy to use. And it works with just a lot of like built-in Python stuff. And it also has a lot of good quality of life features as well. And configuration. So what you need to do to get PyTest to run is just first, have Python and all that installed. And then you have to do pip install PyTest. And then after that, you need to have a folder called tests. And have the files in the test folder start with test underscore or end with underscore test. So for example, we have test underscore widget service.py or widget service underscore test.py, right? And inside the files, we should have the functions. And each function should start with like a test underscore. So def test widget creation. And then use Python's built-in asserts to write tests, right? So let's look at the code. So this code, you do not need to follow along. Do not type along. Do not try to git clone the repo. Just watch what I'm doing, okay? So we have here a simple function that calculates the Pythagoras theorem, right? And we also have a code that makes widgets, right? And we want to verify that this code works the way that we expect. So we're going to first start with unit tests, right? In this case, we can't really talk about units or the end-to-end tests because this is really not a server. This is just like a bunch of example code to demonstrate what PyTest is. So we have this simple function here. And the widget factory here, it makes a widget. And a widget is it's not very special. It's just, fizzbuzz, random holiday name, foobar, whatever, right? Not a big deal. And then this widget writer, it just writes the widgets to a file, right? And we want to test that. So we can only really do unit tests and integration tests, right? Let's start with this. So writing a simple test is very, very simple, right? In the test folder, under the unit subdirectory called testpythagoras.py, I have def test Pythagoras, in this way, right? You just import the code that you want to test, right? You put in the values, and then you do the assert, right? Assert is already part of the Python programming language, so you can just use this. You don't need to use any other fancy asserts. PyTest doesn't really provide you with that. So whenever you want to just assert something, just use assert. So that's why I really like about it. So you can just do this a single test, right? But that may not really test that many cases. So a good thing to know about testing is that the more detailed test cases that you can cover for the test code, it is I think a much better test. So instead of just testing this only one set of values, right? We can test many more values, right? So we have the test cases. We have a list of tuples. And when we can just like iterate over this, like side 1, side 2, hypotenuse, test case, right? And we can just iterate over this and then assert that, verify that this runs as expected, right? Another aspect of PyTest, which is also useful, is if we have a lot of parameters that we want to test, we can also test it like this. This is a perfectly fine way to test. But if we don't want to write a for loop, right, we can use this. It's the parameterized PyTest. So if you notice here, side 1, side 2, hypotenuse, this tells PyTest that this function should have these parameters, right? Side 1, side 2, and hypotenuse, right? And this also tells it that this also tells PyTest that this function should be run with these parameters, right? So what PyTest will do is it will run this function this many times with this many inputs. And you can get pretty creative with this, but this is just another way of doing the same thing, right? So I will let you guys have the GitHub repo after, so you can have a look. But this is a way of doing unit tests. Just a simple piece of code that you want to test in isolation from everything else, right? And to run this, you can run it from VS Code, you can run it from terminal, but what you can do is I'm using something called UV, so I'm doing this. But normally you can just do PyTest, and it will run. But in my case, yeah, you can see that I did all these tests, right? You may ask, there's only 3 tests. Why there are so many tests for Pythagoras? PyTest treats each different test as each different parameter as a different test case, right? So if I just comment these out, yeah, there's less tests, right? So they all treat PyTest these cases differently. Okay, so this is just a simple unit test. Any questions so far? Any questions? No. Okay. And we're going to see how we can test something like this. Our server code is going to look a little bit more like this. We will have something like a class, and then we may have like different dependencies injected into it in the constructor or somewhere else, right? So this, we can see that it gets the holiday name. Yep, there's a typo. It calls the API, and then it gets the holiday name here. And then we put the holiday name inside the widget, right? And we are going to see how we can test this in many different ways. So we have this widget factory with external API caller, right? We can test it using mainly 3, but I guess technically 4 different ways. You can also just use the code on its own, but this is a poor way to test, right? In this case, we are calling an external API. This is a API that will call the public holidays API, and it will just get the holiday from the year and the country, right? And in tests, we don't really want to call the actual resource when we're doing like integration tests or unit tests, because 1, we cannot be sure that the resource will be present or the same during the tests. And number 2, we will be testing many times as we develop. So whenever you make a change or make a PR, we will run tests to verify that the code that you have written works the way it expects, works the way you expect. And then the code that other people have written, which also has tests, are not really affected in the same way, right? Right. So, and also for stuff like APIs or external databases, the network connection, it can always fail. So you don't want the test to fail because the network connection has failed or because you ran out of credits to call the API. So the test should really not have factors outside of your control, is what I'm trying to say. So this is not a really good way to test. This will call the API directly, and this will make the API just slow and just like not great, right? There are three main ways that we can just solve this problem, right? The first is stubbing, the second is faking, and the third is mocking, right? I will first go over stubbing, right? Let's see. So in this widget factory, we have this random int generator, right? This will, generate a random integer between 10 and 99999, right? But what if we want to make sure that this random integer generator isn't random at all for whatever reason, and we wanted to generate a 999 every single time? Then we can use this thing called stubbing. So stubbing is just a replacement of a real method for a function that provides like a predefined output, right? Our predefined output in this case is just 999, and we stub this by using this monkey patch feature that a PyTest kindly provides for us. It will, when you use it this way, right, it will detect when the random package and the randint function is called inside the random package, and instead of calling the actual randint function, it will call this function instead, right? This is what monkey patch does for you, and I do prefer this method because it's just one less dependency that we have to worry about, because just PyTest provides this for us. And another case where this may be useful, because this is just like stubbing a random number, is generating dates. Let's say, hold on, let's go date time. All right. Let's say let's say created date, right? Let's say we want to assert that widget created date is now this time. Oops, never mind. Right. This is annoying. Never mind. Done. I'm trying to demonstrate something, right? When we do this, this will obviously fail, because when we do this, it will create a time at when it gets called, so like a couple of seconds before. But when we test this, we create another instance of time, and it's going to say, oh, this and this are not equal, so the test will fail. So what we can do is let me just demonstrate this. Just yeah. So the actual created time was like a couple of milliseconds before, but since we called the now function again here, right, we can see that even though the created date was properly created, the test fails because the this is actually just not the actual created date, right? So we want to assert that for whatever reason, that the created dates always gets created, whether we put it in or not, right? So what we can do is, let's put the now here. Provide now, return now. So this will provide this. And what we want to do here is monkey patch, set attribute. Yep, set attr is short for set attribute. So datetime dot datetime now should do provides now. Right. And then we're going to try running this. Hopefully it should succeed. Hold on. Oh, it's an immutable type. Hold on. Oh, interesting. I didn't know you could do that. You couldn't do that. But anyway, hold on. I know what to do. Here's now. Datetime dot now. It's now done. That's the widget factory. Let's do is now should, hold on. Oh wait, no, it should be here. Never mind, sorry. And this is why you don't do live coding. Widget. No, wait. Let me just do this. Source widget. Widget. Okay, cool. Source.widget.widget. This should work. That is weird. Anyway, what I'm trying to demonstrate is that if there are like aspects that you want to provide a predefined value for, right? You can just stub it away using this monkey patch method. This will return 999 always, right? So if you want to really verify that, I will just try to debug the code. Debug test. You can see that the actual widget, when we go inside, the random value is 999 always, because we set the random int function to be replaced by this function here. So that is what it does. I'm not sure why the datetime example is not working, but anyway, not a big deal. And this can work for the API caller, right? So this external API caller, right? This is a class, and inside it has the call API method, right? So inside the external API caller, we have the call API method, and we want to replace its invocation with this. So we pass in this function, just like any other variable, and then monkey patch will do its magic and then call this method instead, right? This also works for packages and files. So random is a built-in like Python library, and it does have the randint function. If we look inside, we can see that it has a randint function, right? And we can just replace this call using monkey bash. So if we just run this, it will say Christmas. Hold on, let me just debug the test again. Debug the test. Yeah, we intercepted the call and said, hey, you're not going to return a random number. You're going to return 999. It has been returned. And you're going to return a Christmas for the holiday. So that's what we did. So this is one way to replace any kind of external dependency that you may have in the code so that you can test in a much cleaner and easier way, right? A second method is faking. Stubbing is very simple. It only really returns one value and one value only. But what if you want a little bit more complexity in the, I guess, like a fake code that you're injecting? So we do have this abstract API caller, right? Where is this? Hold on. No, go to here. Go here. Oh, hold on. Where is the API caller? Okay. So we have this abstract API caller. Oh my God. How do I? Sorry. External API caller. Okay. So we have this abstract method in this abstract class. Are people familiar with stuff like abstract classes and interfaces? Are people familiar? Okay, most people are familiar. Are people not familiar? Okay, so an abstract class, or Python really only has abstract classes. I'll just talk about that. So abstract classes are a class that you can define, and when you inherit it, right here, this is how inheritance works. It works as a contract, right? If you label this method inside this class with abc.abstract method, the child class, which inherits this class, has to implement this actual details. So we can say here, we can see here that it says raise not implemented error, because whenever you try to call this, it will just raise a not implemented error. This is to force the inheritor of the class to actually just define all the details over here, right? So we can see here that after inheriting the abstract API caller, it defines the actual behavior of the API calling like logic. But in the actual like test code, we don't want to actually call the API, but we want to have a bit more functionality than just returning a predefined value like a, where is this? Yeah, we don't want to do this, right? We want a little bit more interactivity, right? So what do? We create a fake implementation of the class, right? A fake implementation closely mimics the behavior of the class that we're trying to like really not care about, but it has a little bit, but it's very, very much simplified, right? We can see here in this external API caller, it uses the requests library and it makes a get request, and it actually just returns the data from a server somewhere, right? Instead of doing that, we have a fake API caller, right? We can see that the original API caller, right, it takes in a year and a country code to get the actual resource that we want from the holidays API. So in the fake API, we do something very similar. We have the data as a dictionary here, and the year and the country code as the key to the dictionary. So when we take the year and the country code, right, we put that in a tuple because that's the key, and then we get the data here, right? So this is just obviously very simplified. A real API would not work like this, but it works closely enough that it is an acceptable replacement for a test. In an actual like backend development program, in backend development, this fake class can be a implementation of a database call. Let's say you want to get something from a database, but you don't want a predefined value. You will do something very similar to this, right? So what we do here is I want to, so this fake API caller, wait, let me just do this instead. Fake API caller, fake API caller, right? Let me just, right. So because this fake API caller also inherits from abstract API caller, right? This widget factory, it only really cares that the type of the API caller is abstract API caller, right? Because anything that inherits this will have to implement this method, right? So it doesn't really care if the actual thing gets put into the widget factory or if the fake gets put into the widget factory. So it doesn't really care. So that's how this whole faking thing works, right? We create a fake thing to replace the real thing, and then we put it inside the test, right? And then when we run this, it runs, and it does not actually call the, it does not actually call this. It will call this instead. So you put a debug line here. Like, did I put out the right line? Never mind. Here. If we try to debug this, the execution will stop here because we put the debug point here. And then we can see that we passed in the arguments 2024 and Korea, and then it will just get the data from here because it's not actually calling the real thing, right? Cool. And the final method is called mocking, right? So mocking is where we replace the functionality, and we also want to verify that it has been actually called, right? So what can we do? What can we do? Is this a good example? Hold on. Random number. Let's go random.randint. Yeah, I probably shouldn't be live coding, but whatever. I do want to demonstrate this. Hold on. Mock random int. It would be, let's say 100, right? Mock random number call magic mock walker dot hatch dot no, hold on. So let me do something else. Refactory. Let's say for whatever reason, why is the IDE getting angry? Hold on. Let's say for whatever reason, we are calling the API twice, and we want to verify that the API has been called twice, right? So, but there is no way to verify this if we use the fake API, because the fake API will just call the API, but it won't really record the number of its uses, right? So in this case, we will have to use something called a mock, right? Assert called right. Let's say call count, right? We want to somehow assert that it has been called twice, right? What a mock does, right? It verifies how the method was used and how many times it was used. This is useful in cases when we do something, but it doesn't really return a value for us to verify. If you notice from all the other tests, we only really verify that the widget that we made is the widget that we expect, right? So it does need a value that returns to that we need to verify against. But there will be cases where there will definitely be cases where something like this happens. So let's just say another example. If someone hold on, purchase products, right? Because our example is e-commerce, let's just go with this. It will return the order number, which is going to be 1, but it's also going to right, send email. So this is a side effect that happens when you purchase a product. But since we only get returned this order number, there's really no other way to verify this, that a email has been sent without really just, even though we may inject like a fake email sender into the class, there's really no way to really verify that this works. In cases like this, a mock gets useful, right? A mock. So PyTest doesn't really provide a mocking library on its own. So we have to install something called PyTest mock. It's a plugin, and you can just do pip install PyTest mock, right? And like most other like PyTest features, we can, like how we used monkey patch, we can just use the mocker object by putting it in here. And PyTest will automatically just put this in for you when the tests get run. So first we have this mocked value, right? And then we're going to mocker.patch because we're patching an object. We just put this class here, and the method that we want to mock away is the call API method. And then we wanted to return this mocked value instead of actually just doing whatever it normally does, right? So when we do this, let me just debug test. All right. We can see here in the widget, it properly returned the boxing day value that we have told the mock to return, right? And we can also verify that this, hold on, mocker, let's see the call count. I can't see it here, but anyway, we let the test go run. Yeah. So we can see that it correctly counted the call values. So in this produce widget, we can see that this call API was called twice. Despite not really returning anything that we can verify, since we used a mock, right? We can see that we can verify that this interaction happened exactly twice, right? And we can also assert that the arguments that we used to call this method was 2024 and KR, right? We can see here that in the widget factory, the defaults for year and country code is 2024 in Korea, and we can verify that it was called with these methods, right? So this is the advantages of a mock. Yeah, I was going pretty fast. Oh, wow. It's already over 4 p.m. I think I have to end it here, but I'll take some questions. Yeah. I may have gone a bit too fast. Yeah. Any questions? Any questions? No? All right, cool. Bijan, oh, okay. You have a question?
How many tests we should write for methods?
That's a difficult question. Is it an important method? How many inputs can it take? What kind of like different use cases have you thought about it? It really depends on the method, but it should cover as reasonably as many cases as possible because we don't have infinite time. I suggest writing a case where using the method goes well, a happy path, and also a unhappy path, like what happens when the method is used incorrectly. Does it raise the right exceptions or all that kind of stuff, right? Yeah. And I don't know, for tests that require like lot of different inputs, something like this,
We test for like it.
many values would be usable here. Yeah, something like this. But for like a widget factory, you may not really need way too many tests. This is just for like demonstration purposes. So yeah. Any other questions? Yeah.
Similar question.
Yeah.
I heard that the term called test coverage.
Yeah.
How much should be like in percentage?
So I've always aimed for like around 60 to 70% test coverage. So test coverage is how much of the code base is covered by tests. And I think 60 to 70 is just a good thing to cover for, because not all of the code that you test is going to be of equal importance. And then not all of the tests that you write are always going to be like really be useful at all. So I think really only testing the very critical aspects of your code, such as the logic or the interaction with like a database, I think that'd be much better. Yeah, so 60 to 70% is like good percent to aim for. Yeah. Any other questions? Yeah.
In real, do you write this test by yourself, or or does it some different person? And
You write your own tests. Yeah. I mean, you can write test code for code that other people have written, but you know, it's not something you get like a junior engineer, like someone like Lesser, to do, right? You should have like your own responsibility for your own code. Yeah, you should write your own code. You should write your own test code. Yeah.
can you summarize all of this? A certain summarize.
I don't understand your question.
Can you summarize this session?
So tests are important. There are 3 ways to ignore dependencies in testing. First is stubbing, second is fating, third is mocking. And how to use PyTest is just you should have a test folder. The file should start with the test underscore or end with test underscore, and all the tests should start with test underscore. Yeah. Any other questions? Yeah. Any other questions? No? Okay, cool. I think we can end this here. Yeah.